Chapter 14, Kinetics, Exercise 14.77. If a temperature increase from 10 to 20 degrees Celsius doubles the rate constant for a reaction, what's the value of the activation barrier? We'll use the Arrhenius equation. The equation is this. Alright, this is the equation. K is 8 times this exponential function. If we take the natural logarithm, we'll get this, and we'll get minus, and I will copy this whole thing. Alright, so Ln K is Ln minus Ea over RT. Now we have two different temperatures, and what we need to do is we use this same equation for two different temperatures. We get K1 and K2 at T1 and T2, and then we take the difference between the two equations. So K2 and then minus Ln K1 is equal to, over here, we have 1 over T2 minus 1 over T1. This is the equation we're going to use because the rate constant is doubled when the temperature goes from 10 to 20 degrees Celsius. So K2 is 2 times K1. That means it's doubled, and then when you take the difference, you get actually just Ln2 on the left hand side. And T2 is the higher temperature, 20 degrees Celsius, 293. T1 is 10 degrees Celsius, so that's 283 Kelvin. R is 8.31446 joule per mole Kelvin, and that's it. This is the equation we use to compute E sub A in joule per mole, and this is kilojoule per mole. So in the end, we divide this value by 1,000. So what we do is pretty simple. We just multiply both sides by the gas constant. Put a negative sign here, so we can get rid of this this sign. So E sub A is going to be this whole thing divided by this. Alright, I'm going to copy this, delete this, and then divide it by this. Alright, now we have okay, we should have the value here. Alright, this is in joule per mole, so yeah, because this is in joule per mole, so we're going to enter 23.3 in kilojoule per mole. A mistake. Huh? There's a mistake here. Oh, the mistake is this. Yeah, it's how to use the online calculator. When you do this, this online calculator will do the multiplication first. They will get 16.6 and then take the logarithm. So this is the reason. Be really careful when you use your calculator as well. So after I added a pair of parentheses to compute Ln2 first, I got 47.8, which makes more sense. Alright, now it should be correct. Okay. Again, the equation is right, the expression is right. It's just you want to do Ln2 first and then multiply by R. You can't do 2 times R first and then take the logarithm. That does not make any sense. Alright.